Jim Greene.
Thank you very much, John. What I'd like to do today is to talk a little bit about some of the fabulous observations that John mentioned and a number of others. And we'll start, of course, with Mars. Mars, like Earth, is in what we call the habitable zone, the region that extends around the sun, for which the sun's light on a body about like the Earth is such that water can exist in three phases: liquid phase, solid, and vapor. Now, today, Mars, although it's in the habitable zone, is a very arid planet. And if I can have my first video, what we've discovered using our assets at Mars, looking at the terrain and our ground truth observations from all our rovers, is that Mars in its past had a significant amount of water. In fact, as John mentioned, it had a habitable environment. Curiosity is in a region where water flowed pretty rapidly. So when we think of Mars in its past, we recognize that it was a water world, much like the Earth. It had clouds, it had oceans, and a hydrological cycle. But the most recent observations that are really tantalizing are those that were made with ground-based telescopes in the infrared. These telescopes were looking at the north polar cap of Mars for what's called the deuterium to hydrogen ratio. This is called the D to H ratio. And once we make those measurements and we compare them with Earth, we then can extrapolate back in time how much water really existed on the surface of Mars. Now, I mean water. I don't mean ice, and I don't mean the vapor. And what we find out is really illustrated in the next video. Here we see Mars as it was in the past, but now we're going to paint the oceans. We're going to strip away the clouds. We're going to look through the atmosphere. And what we find is that about 50% of the northern hemisphere of Mars had water. And it had it for a very long period of time, perhaps more than 1 billion years. Current thinking is about 1.2 billion years. Now, in fact, some of this ocean was as much as 1 mile deep. Now, Curiosity is sitting in a crater, not on the ancient shore line of where this ocean would be, but a little inland. But what we do know and what we have found out is that water cycle on Mars was such that it popped over the crater wall, flowed down into the crater, and in fact did this repeatedly over perhaps millions and millions of years, and actually built up that large mountain called Mount Sharp in the center of Gale Crater. So Mars was much more Earth-like in a habitable zone for a very long period of time than we ever imagined. This is really an exciting time. Now, just beyond Mars is a region called the asteroid belt, but it's also a location for which the solar energy is such that beyond a certain location, we call the snow line, further out than the snow line, we find water should be only in one phase, only in the solid phase. But what we're finding is that's not true either. If we look at the next, my first graphic, here we see what Galileo saw, 400 plus years ago, the Galilean satellites, the moons of Jupiter, Io, Europa, Ganymede, and Callisto. And as you can see, they're ordered in such a way with Io close to Jupiter. And the gravity interaction between Jupiter and the moon Io is such, with tidal forces, that it literally heats the inside of Io. It turns it inside out. Io is a very volcanic world. Don't expect any water there. However, the next one, Europa, we're finding at much different location. It's far enough out that the tidal forces don't dissipate its ice shell, but retain enough water in liquid form below an ice crust to really make it an exciting place to look at. So if I can have the next slide. Most recent observations from Hubble have really tantalized us in going to Europa as our future mission. Here we see potential plumes of material, ice, water, ice, flowing out from cracks perhaps in Europa in the southern hemisphere and recoating the surface. This must be what was happening because the surface of Europa is very little cratered. This is just a tremendous set of observations. But even more recently were those, in my next slide, of Hubble observations of aurora on Ganymede. Now, Ganymede is a huge body. It is the largest moon in the solar system, larger than our own moon. It has a magnetic field, which is also a very bizarre thing for a moon to have. But that magnetic field, as it interacts with Jupiter's magnetic field, allows particles to be exchanged between the two planets, or the planet and the moon, Ganymede. And this produces aurora. Now that's great. We can observe this aurora. We've seen the aurora many times, but when we do a detailed analysis of the aurora, we find out something very important. Now the magnetic field of Jupiter actually is pretty twisted. And by the time it gets out to Ganymede, it can really rock back and forth as Ganymede moves through the magnetosphere of Jupiter. We therefore expected the aurora to rock back and forth, but it doesn't. It rocks very little. Now this means that some sort of current arises underneath that ice crust, generating another magnetic field that then stabilizes this aurora such that we see it in a particular place. From those data, we now know that indeed Ganymede has an undercrust ocean. Now we only are just getting tantalizing glimpses of that, how deep it is, but it must be a vast body of water. This changes our perspective of where habitable zones are completely. My next slide. Here we see those Galilean satellites once again. Io is closest to Jupiter, but it's a volcanic world. It's not an icy world. But we know now that Europa and Ganymede have a significant amount of water underneath their ice crust. And in fact, we now believe Europa has perhaps twice the amount of water underneath that ice crust that the Earth has on its surface. With the latest Hubble observations, we're going to include Ganymede now in that habitable zone because water is incredibly important. Now there's some ideas that there may be water in Callisto, but we haven't confirmed that. But at least now we recognize that habitable zones aren't just around stars, but they can indeed be around our giant planets. What we're finding out is that the solar system is really a soggy place.